Once you have selected a contradiction, you can move on to step 7. There is therefore one step 7 per contradiction. In other words, if you change the selected contradiction in your bubble diagram, you begin a parallel step 7 to the first, and so on as you solve the contradictions in your bubble diagram. In this specific case, you are on a step 7 dedicated to a particular contradiction that you have formulated within the framework of the study, namely, having a material that is both flexible and rigid. The first step in this resolution phase consists of associating your two study parameters with the 39 standard parameters of the TRIZ matrix. You notice here that the ease of penetration of the syringe corresponds to your PE1 and that the crushing rate of the material corresponds to your PE2. The first thing to do is to identify among the 39 the one that is closest to each parameter you have formulated. Regarding the ease of penetration of the syringe, if you observe the available parameters, the parameter ease of operation seems to be the closest. Since this is a mechanical aspect related to hardness, you could consider assigning it a mechanical criterion, but for now it is more relevant to align it with parameter 33. Then, for the crushing rate of the material, you identify that a material that crushes harms the main function of the vein, and so you choose the parameter external harm affecting object. By placing the ease of operation parameter on the x-axis and the external harm affecting object parameter on the y-axis, you position your specific contradiction into a generic contradiction of type 33 versus 30. You can see that this generic formulation does not match your two PEs word for word, but it is close enough to be considered relevant. Once this contradiction is formulated, the software will extract statistics on the inventive principles most often used to solve this type of contradiction. You are here suggested to start by exploring inventive principle number 2. By clicking on this principle, you can temporarily leave the application, return to the inventive principles, and examine what is proposed to interpret similar situations in other domains. In the list that appears, you only find suggestions that fall under inventive principle number 2. However, these examples mix two types of information. On one hand, the examples marked auto-scraped, which have been automatically collected by an AI. On the other hand, examples manually entered by a human, which you can filter by removing the auto-scraped tag. This allows you to obtain only the manually entered examples still related to principle number 2, taking away which you have selected. These human examples are generally more reliable and multi-technology, allowing you to consult them one by one and identify those that seem most interesting to you. In this case, you have at your disposal 40 engineering examples associated with inventive principle number 2. You can then try to build a solution by drawing inspiration by analogy from the content of these examples. The bet with TRIZ is that this combination of a well-posed contradiction and a set of suggestions via inventive principles will be enough to inspire you with one or more ideas. This interpretation phase can be repeated with other proposed principles, such as Principle 25, Principle 28, etc. This will allow you to broaden the potential for problem resolution. Once you have an idea, you will formulate it by choosing the principle that inspired you. You are not required to start from a specific example. If it is the label of the principle that inspired you directly, you do not need to select a specific example. You then simply return to the application, display all the solutions, and create a new solution. You give it a title, write a label, and that constitutes your first idea sheet related to your problem. In this way, each member of your team can have a space to either create new ideas or return to the analysis, retrieve the rest of the study, and continue it. You can thus choose a new principle to interpret, or continue browsing the examples to see if one of them suggests other avenues. You can also use keyword filters to target certain properties, such as soft. For example, 2 examples contain this keyword, still stemming from Principle 2. If the web page associated with the example is still online, you can access it. If not, you still have the title, an image, and a descriptive paragraph. In this way, you begin to build your list of solutions, which you can then evaluate in the next phase of your study. Finally, in this Solution Search tab, you have the possibility of using the question-answer mode. Your contradiction can then be translated into a natural language sentence in English or a French-English mix, directly editable via the Edit field. Once your wording is correct, you can select the database in which you want to search. Here, patents. You then add keywords such as syringe, and you get targeted results. The software can then suggest to you, as in this case, 11 patents containing devices potentially relevant to solve the problem. This means that some of these patents are already filed. For example, a patent dated 2020 is still covered by industrial property rights. By reading the content of these patents, if an idea comes to mind, you can write it down and create a new solution sheet inspired by this patent. Of course, you cannot copy the patent as is, but it can feed your thinking. This part of the study is considered complete once you have produced a sufficiently rich set of ideas to estimate that your final solution will be found among them, or that you have enough elements to continue the analysis.